All right. Good afternoon, everyone. Welcome to SLiTHER number 64. I am very happy to introduce Barb Reisner, Cora MacBeth, and Michelle Brooks. They're going to be talking to us about ACS CPT guidelines. And this one's going to be a little bit different than some. We're going to have an initial section here that we record and is postable because we're going to be talking about stuff that is public domain kind of things. And after a few minutes, we'll cut off the recording, stop it, restart it, and make another video that will be available only through the Viper website to registered faculty users. And anyone who is in attendance here will certainly get the link to that. But otherwise, you've got to go through the secret channels to get it. So I've said more than enough. I will happily turn it over to our presenters as we have this interesting discussion today.
Sure, Barb, do you want me to get started?
I thought Michelle was going to start with the information about the guidelines.
Yes,
Sure.
yeah.
Okay. Let me get
I've pasted a link in the chat. So Michelle?
All right. So this is not the fanciest of presentations, but I threw some images together. My name is Michelle Brooks. I'm the Assistant Director of Higher Ed at the ACS in the Division of Education, and I am the staff liaison to the Committee on Professional Training. Barb and Cora are both members of CPT. So I thought I would just give you an overview of the guidelines and kind of show you what the discussion today and how it fits into what we do. So these are really the main pillars of the ACS guidelines, and they center around things like infrastructure, faculty, and staff. What we're trying to look for really in designing these guidelines are the pieces of an educational program, an undergraduate educational program that provides students with all of the things that they need to be successful, at the same time providing faculty with some protections on their time, as well as protections for being able to do things like take sabbaticals and develop professionally. And so it kind of has elements of those things all the way across it. So you can read these just as well as I can. We're going to focus today on two different pieces of it, the skills and proficiencies and the curriculum. So one of the things that we've been trying to do over the last, I don't know, 2 or 3 years since we created the 2023 ACS guidelines is that we've decided that what we need to do is provide resources for faculty if they're doing things like developing a new curriculum, trying to think of ways to scaffold skills and proficiencies throughout their curriculum, and doing it in a way that shares best practices from other people in the approved program world, so that you don't have to start these things from scratch. So let's start with curriculum. And the very basics of the curriculum, or how we build the curriculum, is we start with our basics. So we start with Gen Chem and Gen Chem Lab, these introductory courses. They're not specifically discussed in the guidelines. And one of the reasons for that is that many students test out of Gen Chem, many students take Gen Chem in other places. And so if we're going to evaluate an undergraduate chemistry program, the Gen Chem can be done in a variety of different places. And of course, we have cognate courses to support to support what's happening. So then, building on top of that, we have foundation courses. These are the first courses past Gen Chem in analytical biochem, inorganic, organic, and physical, ABIOP shorthand. We're going to focus on inorganic content today, but every approved program has to have at least an introductory course in one of these areas. Now, these courses are deeper dives beyond Gen Chem, so they're a step above Gen Chem. And then above the foundation courses, we have in-depth courses. And what you'll notice here is that there's no labels on these boxes, right? We require 4 in-depth courses. You as a department choose what those in-depth courses look like. They are typically deeper dives into one of the 5 ABIOPs. For example, the standard in-depth course for organic is Organic 2. Right, so you're diving deeper into the basics of organic. Physical's the odd one out here, and as a physical chemist, I'm proud of that. Physical chemistry, you're normally not building on thermodynamics when you teach quantum mechanics. you can work it in there or vice versa. But typically the first semester of physical we count as a foundation. The second semester, if you choose to offer a second semester of physical, which I highly think you should, is the in-depth course. But you can really choose these in-depth courses, or students can choose these in-depth courses to kind of focus on their interests. We have two areas of content that we require, so we don't necessarily dictate the exact content that should go in these. The documents that Barb and Cora will be discussing today is suggested practices and guidance for what normally goes into an inorganic course. It is not a checklist. It is not a you must put these things into your inorganic course in order to be approved. In other words, it's for somebody who might be coming into a smaller program, maybe has a physical or analytical background, has done some inorganic, and is now tapped to teach inorganic chemistry. This would help guide them in developing those courses. So the content that we do require is green chemistry. This is a new one of this year, and we require that at some point in the curriculum, the 12 principles of green chemistry are discussed, taught, worked into a lab. It's up to you how you incorporate them. And then there's, of course, the polymer we call MSN, which stands for macromolecular, supramolecular, and nano materials, I think. I can never remember our acronyms. But what we're looking for here, again, is about 15 hours of content that is taught throughout the curriculum. It can be in lecture, it can be in lab, and we're looking specifically to see that you're teaching how these materials are synthesized, how they're characterized. And then, of course, overarching everything is labs, right? That chemistry is a laboratory science, hands-on science. And so labs and research, I don't know why I made the research block bigger, is probably a twitch in my hand, but kind of covering all of this as a requirement that students do laboratory work. The research is here. We don't require that students do research, but we do allow research to take place of some of the 350 lab hours that are required. And students can also opt to take research as their fourth class. So this is kind of what the curriculum, this is how it's built up, kind of the philosophy behind how we've done this. By no means is this a static type of curriculum. This allows for some innovation and allows for some teaching in new and different ways. So we're going to look a little bit now at the two sets of skills. And because we're going to be focusing on inorganic content today, I'm going to go through these pretty quickly so that we can get into kind of the meat of this discussion. So professional skills, we have 5 right now that are expected to be scaffolded through the curriculum. So what we're looking for is that you are teaching these things not just in one class here or there, but you are consciously and maybe deliberatively scaffolding these skills through the curriculum. So students are introduced to communication skills, maybe in Orgo 1, and they're learning how to write a very simple lab report. By the time they get to biochemistry, maybe they're writing a more in-depth memo, or they're writing something for a different audience, or they're writing a more formal research-ready looking lab report. So the skills are scaffolded. This one here, this is left open because as the world evolves, the skills that we need are going to change. And again, these guidelines are a living document, so we allow for new things to come in. Systems thinking is the latest piece in here, and right now it's not listed as a critical requirement, which are things that are absolutely essential to the to get approval, but there are best practices and aspirational goals for incorporating systems thinking. So the guidelines, just briefly, have kind of 3 different categories. They're not necessarily tiers, they're categories. There's one category called critical requirements. Those critical requirements are the rules, right? You have to meet those in order to have ACS approval. The normal expectations and markers of excellence, they're guidance for programs who want to expand their offerings in one or more areas. Every spring, we have a Markers of Excellence Symposium where we highlight programs that have done an exemplary job in one or more of these guidelines. This year's Markers of Excellence Symposium is going to be Monday, the 24th of March. in San Diego, and it's focusing on the incorporation of green chemistry into the curriculum. So look for it in the program. In addition to professional skills, we also have lab skills. And so these are the areas that when you are teaching your labs that the students should have instruction in some way or the other. We have been working lately on rubrics for these that will be available to the broader chemistry community as they're approved by CPT. So that's a kind of an overview of what we do. And I'm happy to throw this back to Cora and to Barb. And of course, answer any questions that you have. Sorry, I forgot about that part.
It's as quiet as my 8 a.m. class.
Apparently.
Either you all multitasked during that part or it was very clear.
I think it was very clear, but I stare at these all the time.
Yeah.
Not as much as you, but
So should we move on to phase 2?
I think we can move on to phase 2. So I'm going to give me just a minute.
No problem.